chemical reactions undergone by alkene member is addition reaction. Addition reaction. Now this is the difference between saturated compound, or the difference between the alkane that we did last week and that of the alkene we are dealing with now. It is only the ENE compound that will undergo addition reaction. These ones undergo substitution reaction, the ANE. Now the difference between alkane and alkene is that all the ENE compounds undergo addition reaction. The ANE compound undergoes substitution reaction. Now what is addition reaction? Addition reaction is a reaction in which addition reaction is a reaction in which unsaturated compound becomes saturated. That means the main aim why compounds undergo addition reaction is for them to become saturated. That means the double bond will be broken. And when you want to break a double bond, a molecule of two, anytime you have a molecule of two, we break one line. Anytime there are two molecules, that will be sufficient to break one line. Now let us look at the various types of addition reactions. For today, we will be looking at 2 or 3 types of addition reaction. Under the addition reaction, which is used by unsaturated compound to become saturated, we will now categorize them as 1. Hydrogenation reaction. Hydrogenation reaction. Hydrogenation reaction. One of the types of addition reaction is hydrogenation reaction. Hydrogenation reaction is a reaction in which hydrogen is added to a compound. So anytime you add hydrogen to unsaturated compound, for it to become saturated, you call that hydrogenation reaction. So hydrogenation reaction is a reaction in which hydrogen is added to unsaturated compound to become saturated under the influence of nickel catalyst. The catalyst nickel must be present and the temperature must be between 180 degrees Celsius to 200 degrees Celsius. So for addition reaction or hydrogenation reaction, which is a type of addition reaction to occur, nickel catalyst must be there and then the temperature must be kept between 180 degrees Celsius to that of 200 degrees Celsius. Let us look at the format. Now this is alkene because it has got double bond. That makes it unsaturated. 1, 2, 3, 4. Now we are going to add hydrogen. The moment we add hydrogen to this compound, we call it hydrogenation because it is hydrogen that we have added. We said a few minutes ago, not even we, I said a few minutes ago that anytime you add a molecule of 2, it will break a bond. Now when you look at the hydrogen I have added, there are 2 molecules here. The 2 is attached. So it is capable to, any 2 will break one line. If you have 2, it will break one of the lines here. We have 2, so you break one. When one line is broken from that reaction, you are now left with one line in between the 2 carbon atoms. No more 2 carbon atoms or 2 lines, but just one because of the presence of the 2 here. Now each carbon atom will have valency of 4. 1, 2, 3, 4. 1, 2, 3, 4. We now add. Initially, I have 2 hydrogen atoms attached to 1 carbon here. I will put them this way. 2 hydrogen atoms here again. Initially, that was what we are having. Now we have added 2 hydrogen atoms again. One is coming at the starting here, and the other one ends. Now this one is the ENE, which is ethane, and this one becomes ethane, the ANE. So that means unsaturated compound with double bond has become saturated. That is one of the main reason for undergoing addition reaction. They undergo addition reaction so that they will break their double bond, so they become saturated. Now, what will be the practical application of hydrogenation reaction? How are we going to apply hydrogenation reaction in industries or factories? When you want to add oil, in the hardening of oils, hydrogenation reaction is used in the hardening of oils. So anytime you want to harden oils, you use hydrogenation reaction. Have in mind the nickel catalyst must be there and temperature must be around 180 degrees Celsius to 200 degrees Celsius. That is the first type of addition reaction, which is hydrogenation reaction. It takes us to the second type. We are looking at the second type of addition reaction. And the second type of addition reaction is known as halogenation reaction. Halogenation reaction. Halogenation reaction is a reaction in which halogens are added to unsaturated compound for them to become saturated. Anytime you add halogens, the halogens that we add can be chlorine, can be bromine, it can be iodine, it can be fluorine, etc., etc. Now, anytime you add any one of these substituents or these halogens here to unsaturated compound, that reaction is halogenation reaction. If it is hydrogen that you add, you call that hydrogenation reaction. But we are adding halogen, so we call the reaction halogenation reaction. So anytime you do halogenation reaction, a compound, if it is on alkene, a compound known as 1,2-dihaloalkane. The format is 1,2-dihaloalkane. So anytime you do halogenation reaction, the product form takes the pattern of 1,2-dihaloalkane. Let us look at the format. We have unsaturated compound here, which is ethane. Now let us say we are taking any one of the halogens here. Let us say chlorine. When you understand the format here, you can use it to even analyze when it is iodine or chlorine. When that is done, the moment we are adding a molecule of 2, it will break one of the bonds here. You are now having a single bond this way. Single bond. Carbon has got valency 4. 1, 2, 3, 4. 1, 2, 3, 4. Now we have 2 hydrogen atoms attaching. Any carbon atoms here has got 2 hydrogen. One is here, the other one is here. Initially, again, this one has 2 initially. 1, 2. We have added 2 chlorine atoms. One of the chlorines will come here, the other one comes here. When you go to the nomenclature of alkane, you start the numbering from wherever, because this is a branch, this is a branch. You can start from number 1, number 2. In this case, the chlorine here is at number 1, so we use 1. Chlorine again is at number 2, we use 2. There are 2 similar. These are similar. So when we have 2 similar branches, we call di. Now they are halo. The halogens here is chlorine, and then it becomes chloro. 2 carbon atoms is ethane. It is now in ANE because it is moving from ethane here, ETENE, ethane from ENE, which qualifies it to be unsaturated. It is now becoming ethane here, which becomes the saturated form. If it is bromine that you add, it becomes 1,2-dibromoethane. If it is fluorine, you call that 1,2-dichloroethane. That is how you can do the halogenation reaction. Let us go to the other addition reaction. You can also add, the other addition reaction is the addition of H2SO4. Addition of H2SO4. When you add H2SO4, anytime you add H2SO4 to alkene members here, preferably ethane, you produce a compound known as ethyl hydrogen sulfate. Ethyl hydrogen sulfate. Ethyl hydrogen sulfate is produced. So the compound known as ethyl hydrogen sulfate is produced. Anytime H2SO4 tetrasulfate 6 is added to ethane, you produce a compound known as ethyl hydrogen sulfate. Let us get the format here. I have got C2H4. This is ethene. This is ethene. We are adding that to H2SO4. When you add this one to H2SO4, we are forming a product called ethyl hydrogen sulfate. If you recall, we said ethyl is C2H5, hydrogen is H, sulfate is SO4. That is what you get. So if that is the case, when you do this one, we have C2H5. So this C2 comes here. H5, that means we have already 4 hydrogen atoms here. 1 hydrogen from here will come here for it to be 5. When 1 hydrogen moves from here to there, you get C2H5 now. H5. Instead of 2 of them, 1 already moves to this. So we are left with 1 hydrogen atom. And then we have HSO4. That is ethyl hydrogen sulfate. Now that ethyl hydrogen sulfate that we have produced, ethyl hydrogen sulfate now will undergo hydrolysis. That means when you add water to it or you boil that in water, that is hydrolysis. When you hydrolyze ethyl hydrogen sulfate, another compound will form. And how are you going to write the formation of that compound? We are going to hydrolyze ethyl hydrogen sulfate. Ethyl hydrogen, ethyl hydrogen sulfate is produced. At this point, we are now going to hydrolyze it. We add water to it. When that is hydrolyzed, two compounds are going to be formed. How are you going to get them? When you now look at the format of the analysis here, the two hydrogen atoms from here will come to the SO4. When two hydrogen atoms come to the SO4 here, we are going to get H2SO4. That is what we have. Plus. Now let us add the other molecules that are left. We have C2H5. We have left with C2H5. I will write C2H5. We have this oxygen here and this hydrogen. Already the C2H5 is what I have transferred. I am still left with oxygen here and hydrogen. That becomes oxygen and hydrogen. But C2H5 OH, a compound with OH, is known as ethanol. Ethanol. So ethanol is produced in that particular format. Anytime you add H2SO4 to ethane, ethyl hydrogen sulfate is formed. Ethyl hydrogen sulfate is hydrolyzed. That means by adding water molecule to produce ethanol. That is one of the ways in which ethanol is produced. Those of you who make use of alcohol by the name of ethanol is produced using this format. And for today, I'm going to stop at this point. Thank you and God bless you.